In this next Config Lab video, you think about IP addresses, you do some subnetting math, you choose some addresses, then you configure them in routers, and at the end you can even test to make sure those addresses are pingable. Let's jump in and review this lab. So this content you'll find mostly in the CCNA Official Cert Guide Volume 1, Part 5, Chapter 17, which talks about how to configure those addresses on routers. This lab, there's the direct link. It ends in CLab 117. It's a config lab. All of those labs begin with the top half of the blog page that basically sets up the lab. And then at the bottom, it gives the answer and explanation. And in the middle, there's a short section that says, hey, please do the lab now. That's where a lot of your learning happens. And you can do it in Cisco Packet Tracer or Cisco Modeling Labs Free Edition. For this lab, I've made an intro and a review video. This is the review video, which lets you dig in a little deeper to what the answers mean and also get a few more tips about how to verify in CML-Free. Well, for that inner subnet, the math was the easiest part versus the other subnets, right? So here are the 4 addresses that you should have come up with. The instructions said use .1, 2, 3, and 4 for routers 1, 2, 3, and 4. So that was easy enough, right? To configure those, though, you'd get into interface config mode under the gigabit 0/1 interface and configure the IP address command with the address and the mask. Now, the mask is required that it be in dotted decimal format instead of prefix notation. The lab presented them in prefix notation, so you have to convert /24 to 255, 255, 255, 0 in order to know what to configure. And in this case, we've got router R1's address 172.16.100, which is from the subnet ID .1 as instructed in the lab. Then on R2, R3, and R4, it's almost the exact same config, but the addresses end in .2, .3, and .4 as instructed. Now, the hardest math came in the other 4 subnets, right? The outer subnets, if you will. So think of them as locations, upper left, upper right, lower left, lower right. And let's look at upper left to start. It had a mask of /27. So at some point, you would need to convert that to a 255, 255, 255.224 dotted decimal mask to configure it. However, the problem statement gave us the subnet ID, and it turns out the numerically lowest or first usable address in any subnet is 1 bigger than that, 1 bigger in the 4th octet. So the first usable address is 172.16.1.1 instead of 172.16.1.0. Easy enough there. But whatever your method, whether you use the methods described in my books or not, you'd have to do the math to say, well, what are the addresses in the subnet? The 4 main addresses, and that includes the broadcast address, which in this case ends in .31, and the numerically highest or last usable address in the subnet ends in .30. And that's the one that, per the lab instructions, that you should use on the router. So there's the address that we'll see in the router configurations coming up. All right, if we follow that logic through the other 3 subnets, we see this upper right subnet, which had a mask of /28. Its subnet ID happened to end in .64, so its first address is 1 bigger, .65. Its last address turns out to be .78, with .79 as the broadcast address. And then lower left with a /29 mask in this case, there's the subnet ID that we were given. The first address is 1 bigger in the 4th octet. The .174 address is the one we'll configure for the router, and there's the subnet broadcast address ending in .175. Last one, I won't read all the numbers to you. You can hit pause and read them there if you like, but in the config, we'll see those there. Now, just as a reference, here are some popular masks that you'll see in prefix notation and in dotted decimal. The lighter colored ones are the 5 different masks we see in the 5 subnets in this design, if you just want to see them for reference. All right, let's look at that configuration. So now on the outer interfaces, in the drawing, we have the IP addresses in orange that I showed in that table a few moments ago. So then if we look at the configuration on R1, its outer interface is gigabit Ethernet 0/2. So there it is. And then we've got the IP address command with the address that's the numerically highest number in the subnet, along with the dotted decimal mask of 3 255s and a 224. Then on router R2, the address from the figure / table, along with its mask of 255.255.240. R3, with the address that ends in .174 with its mask, and then R4 with its address that ends in .254, as it turns out, with this mask that ends in .192. So let's talk about pings for a moment just to verify this. You can see the config, and if you trust the math, you might trust that you've done things right, but let's make sure it works. So I've got a couple of PCs in the design here just so you can test. And you should look at the configurations, but the PCs are configured with the numerically lowest addresses in their respective subnets, and they're configured to point to their respective router IP addresses as their default gateways, all right? But you can check my work to make sure I configured those correctly. So what should work right now? If you went to those PCs and started pinging, what should work? That's the question. So if you go to PC1 up here, it should be able to ping both of R1's addresses. Now, the nearby address on router R1 that's in the same subnet, well, of course it ought to work, right? The interfaces are up, you've configured the lab correctly at this point. But also when PC1 pings the other router R1 IP address, 172.16.100.1, the packet gets to R1, R1 looks at it and says, hey, that's for me, that's for one of my interfaces, the interface is up, I know how to reply, and it replies back. However, if PC1 tried to ping either of R2's addresses, that'll fail. Why? Well, we haven't turned on any routing protocol yet, so R1 and R2 are not dynamically exchanging routes. And you can turn this around on the flip side. PC2 can ping its default router address. It can ping the other IP address on router R2 and get a successful reply. But when PC2 pings either of R1's addresses, it won't get a reply. All right, so that's the state we're in. Now, I've just shown half of the diagram because that's really all you need to do to get the idea for testing, but the same combination applies between any of the routers and PCs here, all right? So you can test that by pinging from each PC all four addresses. And just to organize the problem, let's say you connected to PC1. Here are the four pings you need. They are in the order of nearest to furthest away addresses. So if you look at those four addresses on the right and hit pause, you'll see it's PC1 pinging this address, then this one, so the two router R1 addresses, then the bottom R2 address, and then the top R2 address, which will fail. All right. And then if you wanted to try it also from PC2, in this order, you're pinging from PC2 its default gateway, the other address on R2, then an address on R1, and then the furthest away address on R1. Those last two should fail. So if you'd like to hit pause and go try that if you haven't before, now's a good time, but I'm going to do a quick demo while you're here. So I've got the packet tracer file open. It's just like the one you would have downloaded if you had copy and pasted the answer configuration in, those four commands to configure two IP addresses, one per each of the two interfaces, into all four of the routers, all right? So that's my starting point, and we see all four routers there in the center of the diagram, and if we hover over PC1, it should pop up a window, and we see the address is 172.16.1.1, as promised, with a /27 mask, and if you look a little past up to down the center, it says gateway 172.16.130, which is that address we just configured on router R1. And there's show IP interface brief that shows 172.16.130 as the address here on router R1, for instance. So just confirming a few details there. But if I click on PC1 and get that up on the screen, get to desktop, command prompt, I can do those ping commands we just talked about. So let's ping the default gateway. What is it, 1.30 that we just talked about, and there we go. So we're getting a positive response. So the other or far side address on router R1, 172.16.100.1. Remember, that's the one we chose. .1 is the last octet because of the convention of use the router number as the last octet. That one works because PC1 sends the packet to its default gateway. That's R1. It can send the packet back to PC1. Now we get to the ones that aren't going to work. Ping of R2's IP address in that center subnet of 172.16, is it what, 100.2, right? Instead of 100.1, 100.2. And now we're just going to have to sit here and wait on the timeouts to occur there. Timeout, timeout, and maybe I won't wait for all of those. And then just to prove it out, what do we got? 192.168. There's the address on the outer LAN subnet on router R2. And that one we get a little different message to. We get a destination unreachable message telling us, hey, R1 doesn't have a route to forward that packet. All right, so that's proof of the demo on that direction. And we can do the same thing here with PC2. With PC2, hovering over the icon in Packet Tracer lets us confirm its address is 192.168.165, numerically lowest address in the subnet. And it points to the .78 address as router R2's address. And if we get into router R2's console for a moment, show IP interface brief confirms 192.168.178 as that address we just configured. And then at PC2, we get into the command prompt option and we can do those commands, right? So ping, I'm having a look at my notes. 1.78, yes, that is router R2's IP address on that same subnet, PC2's default gateway, if you will. Then let me type first. That's the other interface's IP address on router R2. That one works. But then when we move on to start pinging addresses over on router R1, like its IP address in that central subnet, that one fails. It times out because it turns out R1 doesn't have a route to send the packet back to PC2. I'm going to hit Control-C and not wait anymore. And then final one, we've got 72.16.1.30 is R1's IP address on its outer subnet, and that's the one for which we have a different issue in the messages, but we see that the ping failed. If you're using Cisco Packet Tracer, you're done. If you're using CML-Free, I've got a few more tips for you, especially about that router as many hosts feature. So as a reminder, in CML, it's different interface IDs than packet tracers. So instead of these gigabit interfaces that you see over here, we'll have Ethernet interfaces, but the numbers are the same. G01 is E01, G02 is E02, and I'll show it to you graphically there for just a moment. All right, so that's one thing you have to keep aware of. The other is when you import the CML file that I've supplied, the top part shows all these devices that match the lab exercise. I've placed them in a little different location because I want to make the graphic work without all the lines crossing. And here's our router as many hosts. That's where we've got one router instead of 4 PCs, and you're going to connect to the console of that one router and do commands that in effect tell it, do this ping command like your host 1, and do this ping command like your host 3, and so on. All right, so I'm going to demonstrate that here in just a moment. So just to emphasize the point, think again about a subset of the figure with those 2 PCs in it with their IP addresses shown up there at the top. So what I've done in that CML file is I've pre-configured this one router that replaces the PCs so they act like both or all 4 of those PCs in this lab. So that when you do a command like these, ping VRF host 1, it actually means ping as if you are host 1, PC 1 in this case, but the correct syntax is generically host 1, host 2, etc. Ping as if you're host 1, this IP address. So this would repeat the same demo and exercise we just talked about in Packet Tracer, but here from CML-Free. And if you wanted to do it and act like you're at host 2 or PC2, ping VRF host 2, and then the same IP addresses. Those are the same IP addresses in the same order we saw. So let me do a demo of that just to let you see it in action. So here we go. We've got this workbench with the core part of the lab up at the top, the routers and the switches have all default config. And then we've got this one router as many hosts, which is my way to let us overcome the 5-node limit in CML. So this one router in this lab represents 4 different hosts, and it lets us test in this way. So let me demonstrate the test. And here's the command prompt, but instead of ping and then the address, I do VRF host 1 to mean I'm pinging as if I'm host 1 in this case. And that will cause the packet to be sent into switch SW1 just like it would have been in the original lab diagram. All right. And what do we want to ping? Well, our first ping test was to router R1's IP address on the same subnet, which was 172.16.1.30. So there we go. Ping as if we're host 1 to our default gateway address. That worked. Then ping VRF host 1. Ping as if you're host 1 to 172.16.100.1. That's R1's IP address on its other interface. And that worked. All right, so just like it did in the packet tracer demo, but now we're doing it in CML. Ping VRF host 1 to the next address in sequence that we wanted to practice, which was, let's see, 172.16.100.2, which is R2's address in the central subnet. And now we get timeouts happening here. And I'm going to get to wait for those here. And then one last one just to be complete. Ping as if you're host 1 to 192. The other side IP address on router R2. And again, it doesn't work. We get some U's that signify those same unreachable ideas that we saw in packet tracer. Now you can turn around and do the same thing from this console to test as if you're at host 2 or host 3 or host 4. So let's do just that. So if I up arrow that last command, now that's a ping to PC2's default gateway address, router R2's address in that subnet where PC2 is. If I use the generic term host 2, ping as if you're host 2 to that address, well, there you go. Now it's doing a ping as if we're host 2. All right, and that one worked. And we can continue down that path, ping VRF host 2 and ping the next address, which is 172. R2's address on its other side. So remember, PC2 should be able to ping both addresses on router R2. So we've just shown that working, but it should fail when trying to ping the IP addresses on router R1. So here's R1's central subnet IP address that we're pinging from host 2. It's failing. And then just to round out the demo, we'll do the same thing, ping VRF host 2, meaning as if we're host 2, to 172.16.1.1, which, well, not 1.1, 1.30, which is router R1's IP address in its outer subnet. And it fails. We also get those U's, meaning there's an unreachable issue. So whether you did the lab first and then watched the video, or watched the video and that got you into lab doing it, either way, I hope you did the lab as well. Hope you got a lot out of it. Hey, if you're new to the channel, you know the drill. It's YouTube. And of course, likes, comments, and shares are always appreciated. Thanks for hanging out. We'll talk to you later.